Yo, what's up guys? So let's try to do this integration question here. So got a big square root, 1 minus x squared to the power of 3. This one feels like we're going to need to use a substitution. They didn't really give us one, so we're going to have to use our own intuition. So we're going to say let x equals 2. Anytime you see like 1 minus x squared and you've got a big square root on top of it, you might want to use this one. So the fact that sine square plus cos square is equal to 1, and if you move one of these guys to the other side, like this is where that 1 minus something squared may pop up, right? 1 minus something squared. So I'm going to say x equal to sine theta. Okay, that's what we're going to let x equal to. Now, if I differentiate this, dx on d theta equals to differentiate sine, we should just get cos theta. And let's say dx equals to cos theta d theta. Yep, now let's come over here and let's say integrate big square root 1 minus sine square theta cubed. And here we have cos theta d theta, which equals to, so this is where 1 minus sine squared is just cos squared cubed. Oops. So if I have a big square root, so square roots and squares should just cancel. We just have cos cubed theta and then cos theta like this. Which means I have cos to the power of 4 theta. Oh my god. The way I'm going to write it is cos square theta squared. So that's the same thing, right? Power of 4. And I write it like this because this is where we're going to need to introduce a double angle. Man, this is a hell of a question. So we're going to use cos 2 theta is equal to 2 cos square theta minus 1. Which means cos square theta is equal to half cos 2 theta plus 1. So I'm going to say half cos 2 theta plus 1 squared. So we're doing that thing again where we're trying to reduce the powers down to a linear power where we can integrate it. So let's pull out the quarter. Cos squared 2 theta plus 2 cos 2 theta plus 1. 1 over 4. You see we have another one. We have another cos squared, right? And we just made a formula for it, this one here. But that's for just theta turning into 2 thetas. So since we already have a 2 theta, this should turn into cos 4 theta plus 1 right? And here, again, I don't really like working with fractions inside the integral, so I'm just going to pull the half out. Which means here I should times by 2. Cos 4 theta plus 4 cos 2 theta plus 3 equals d theta. Now everything is integratable. So sine 4 theta over 4 plus 4 sine 2 theta over 2 plus 3 theta plus c. 1 over 8. Cool. Okay, so that's pretty much the hard integration part. Okay. This is in terms of theta, right? I'm pretty sure the question didn't give it to us. Yeah, it gave it to us in x's, so we're going to have to put it all back in. Okay, so where is the substitution? That's the one that I used. X equals to sine theta, right? So we're going to have to try and replace all these with x's. Okay, and the one that we used before was x equals to sine theta. Now it should be easy enough to get this guy and this one, but this one it looks like we might have to do a tiny bit of work. Okay, so one way we're going to find this is first of all, I'm just going to draw a triangle. Let's draw a bigger one. If this was theta, and x is x over 1, right? We know sine theta is opposite over hypotenuse, which means the adjacent is just 1 minus x squared using Pythagoras. So why do we need to do that? Because this tells us information about cos theta. Cos theta is adjacent over hypotenuse, which is just 1 minus x squared. Okay, and sine theta is just x, which we started off with. So when you come over here, we can say 1 over 8. Let's expand this guy out and say 2 sine 2 theta cos 2 theta. So that's a double angle divided by 4. And expand this one as well. 4 sine theta cos theta plus 3 theta. Okay, so we now know sine theta and we know cos theta. We also should be able to find theta very easily because it's just the inverse of any of these ones. It's just sine inverse x. Okay, and the last thing becomes finding sine 2 theta and cos 2 theta. Now, of course, you can expand this further into single thetas. But what I think is better is we can just focus on finding what sine 2 theta is. So sine 2 theta is 2 sine theta cos theta. And we just found the sine theta is x. And cos theta is 1 minus x squared. Right? So that's sine 2 theta. So that's all we can do. I'm going to try to sub everything that we have so far. 1 over 8. This cancels out to become half. Sine 2 theta is 2x, 1 minus x squared. Cos 2 theta, let's just say that is 1 minus 2 sine square theta. Right, that's what it is. Plus 4 actually this is just 2 sine 2 theta, right? So that's 2 times sine 2 theta. Plus 3 sine inverse x plus c. Okay, so half times 2 cancels out, so we have this one multiplied by 1 minus 2 sine theta was x, right? So that's 2x squared plus 4x, 1 minus x squared plus 3 sine inverse x. Yeah. And we're pretty much there, but I can see one last little bit of simplification that we can do. And that is, if you expand this first one out, like if you expand that with this 1, that should be able to simplify with this. Okay, so we have 1 on 8. That will become 5x minus 2x cubed 1 minus x squared. Actually, there's a better way to do this. Because if you add those two things, we get 5. We should just say x. Yep, this is the answer. Yep, that is the final answer. So hopefully that wasn't too difficult. For extension level trig, this is probably as difficult as it would get. I will say one thing, that it's not necessarily difficult, because once you understand how to do it, if you can understand the idea, it's actually just a lot of algebra more than anything. But yeah, I would say take your time to digest this sort of question and try to do a lot of practice. And thanks for watching. I'll catch you in the next one.